So hi everyone, today our group 3 are going to present about assignment 2, which is pigeonhole principle demonstration. First of all, let me introduce our group members. The first one is Muhammad Asfanazan bin Muhammad Kamil, and the next one is Intan Nuraisha Shafika binti Shamsuddin, and the third one is Nur Intan Najla binti Syed Zohair, and the last one is Nur Fatin Elisha binti Abdul Razli. Let me explain about the pigeonhole principle. What is a pigeonhole? The pigeonhole principle is a fundamental concept in combinatorics and mathematics that states if more items are put into fewer containers than the number of items, at least one container must contain more than one item. Applications of pigeonhole. In a number of theory, the pigeonhole principle can prove the existence of certain properties within a set of a number. For instance, it can show that within any set of n plus 1, n plus 1, n plus 1 integers, there exists a pair of integers whose difference is divisible by n and n. So in a graph theory, the pigeonhole principle is used to prove properties of graph such as the existence of a subgraph with certain characteristics. For example, in any group of people, some subset of individuals will have mutual friendships or mutual non-friendship. I'm going to explain about step-by-step algorithm about this pigeonhole principle. So the first one, initialize data structure. In here, we need to create an array day of week of size 7 to represent 7 days of the week. For example, like Monday, Tuesday, Wednesday, Thursday, and so on. So the next one is initialize all elements of days of week to 0. The second one is input data. Get the total number of the children, which is 12 in this case. And the third one is about the assign birthdays randomly with using simulations. For each child, from 1 to 12, randomly assign a day of the week. So increment of the count for the corresponding day in the day of week of array. The fourth one about check for the pigeonhole principle. Like we have to iterate through the days of week array, check if any day has a count greater than or equal to 2. If found, set the statement true, flag to true, and break the loop. The fifth one is about the output result. Here we're going to display the counts of children born on each day of the week. Output whether the statement is true or false.
Okay, in this slide we're going to present about the explanation of the source code for main menu GUI interface. As we can see here, in this interface we provide the title is pigeonhole principle demonstration. In this interface we also provide 4 buttons, which is for case 1, children born on the same day, and the second button is case 2, family member on the same day, and case 3, children sleeping in bedroom, and the last one is the exit button. The source code for the name of the button, the source code is J button case 1 button equal to new button, and we provide the title what we want to put in the button we want. So the background and foreground and preferred size, the source code is case 1 button dot set background, and we provide the color what we want, which is we provide it is steel blue, and the foreground the color we provide is white, and the preferred size, the dimension we put is 340. For case 2, for case 3, and also the exit button also provide the same thing. To make sure, after we click on the button of case 1, case 2, case 3 or exit button, the source code the button action we put the case 1 button dot add action listener as pigeonhole principle GUI case 1 equal to new pigeonhole principle GUI case 1 dot set menu main menu GUI dot this case 1 dot set visible in column true, and also the set visible in column false for all the 3 button, and also include the exit button the same source code. Okay, now we will go through to the next GUI interface, which is the children born on the same day. Okay, this method using the calculate pigeonhole in column is designed to simulate the pigeonhole principle using randomly generated data. It calculates how many children are born on each day of the week and determine if there are at least 2 children born on the same day. Okay, for the method implementation, the method begins by retrieving the total number of children, which is the total children, from a text field, total children field. An array days of week is initialized to store count for each day of the week. We're using random assignment. We're using a random object. The method iterates total children times assigning each child to a random day of the week. We're using the integer day. Okay. For counting children per day, the method increment the count in days of week corresponding to the randomly chosen day for each child. For result compilation, a string builder result is used to compile the output. An array of day names is defined for reference, and for the output generation, the method iterates through days of week to generate a formatted output detailing the number of children born on each day and whether at least 2 children share the same birthday. And for the final statement, it checks if any day has more than one child, if the statement is true, and appends a final statement indicating if the pigeonhole principle holds true based on the generated data. We also use the exception handling. It includes a try catch block to handle potential input error, which is invalid number format, and provide appropriate feedback to the user through GUI component, which is the result area and statement label. Okay, for the visualization, GUI interaction, after execution, the results are displayed in a text area, result area, and status label, statement label within our graphical user interface. Okay, application of pigeonhole principle. This method vividly illustrate the pigeonhole principle in action, showing how statistical analysis can verify the likelihood of shared birthday within a randomly distributed set. Okay, with further development, this method could be expanded to analyze larger dataset or integrate additional statistical metric for deeper insight. Okay, this presentation has provided with a clear understanding of how Java information using the calculate pigeonhole in column method to simulate and demonstrate the pigeonhole principle.
Assalamualaikum and hi, my name is Intan Narsha Syafiqah binti Samsudin. My metric number is 2858812. So I will explain about the source code of family birthday. The calculate birthday method is responsible for generating random birth month for a specified numbers of family members, and also for counting and displaying the number of family members born in each month, and indicating whether there are any months with more than one family members born. For the line integer total members, integer parser in, this line retrieve the total number of family members from a text file and parser it into an integer. An array months of size 12 is created to store the count of birthday for each month. And random object also is initiated to generate random numbers. And for the loop, a loop runs for each family members, generating a random month between 0 and 11 corresponding to January to December for each member, and incrementing the respective months count in the month array. For the Boolean line, this could check if there is any month with more than one family's members per day. A Boolean statement true is set to true if such a month is found. The result string is updated to reflect whether the statement there is at least one month with more than one family's members per day is true or false. For the line result.set text area, the result string is set to a text area for display. The statement label is cleared, presumably to reset any previous message.
Assalamualaikum. My name is Muhammad Asfanazan bin Muhammad Kamil, metric number 284481. So I will be representing about the source code of the children bedrooms. So this Java method calculate bedrooms is to calculate and display the distribution of children among 4 bedrooms with additional checks to see if any bedrooms has more than 2 children. The method details for the initialization and input passing, we use integer of total children, So it will retrieve the total number of children from the text field and convert it to an integer. And then if this fails, the input will throw a number format exception for the array and random setup. Uh, the source code is the integer bedroom equal to a new integer size of 4. So it creates an array which is bedrooms of size 4 to represent the 4 bedrooms. So it is to initialize a random object for generating random numbers. So and then for the assigning children to bedrooms, we use also integer. For the bedroom, it iterates over the total number of children, and for each child, they will be placed randomly. Select a bedroom from 0 to 3 to increment the corresponding array element. And then for the building result string, we use string builder result equal to new string builder. So the result construct a string summarizing the number of children in each bedroom, and it will check if any bedroom has more than 2 children and adds corresponding message to the result string. And then the checking the overall condition with boolean statement true equal to false. So the boolean is initialized with variable statement true. It iterates over the bedrooms array to check if any bedroom has more than 2 children, and it appends the result of this check to the result string, which is the next one. So for the display result, we use the result area, and then the set test result is constructed result string, and it will include the text of statement label. And then for the last one is the exception handling. So the exception handling is to catch any number format exception that occurs when passing the input. It clears the result area and display an error message in the statement label, which is please enter a valid number. So this interface and this source code is the method to calculate how children are distributed among 4 bedrooms, and it uses random assignments for children to bedrooms. It will also checks and reports if any bedroom has more than 2 children, and it handles invalid input gracefully for showing any error message.